In 2017, Iran unveiled something that froze military experts across the globe. At a Tehran defense exhibition, under a barrage of camera flashes and the adulation of high-ranking generals, a new tank slowly rolled from its tribune. Iranian officials proudly declared it the pinnacle of national tank engineering. The machine bore the name Karrar, translated as attacker. But the illusion shattered instantly. This supposedly 100% Iranian tank bore an indecent resemblance to Russia's T-90M, the flagship of Uralvagonzavod, and one of the planet's premier production tanks. The identical turret contours, the same low, predatory silhouette, the identical layout featuring a distinctive rear niche. Even the explosive reactive armor blocks were positioned almost as mirror images. Iran's defense minister, Hossein Dagan, publicly assured journalists the Karrar was entirely the work of Iranian engineers. He claimed it not only matched but potentially surpassed the T-90M in critical performance metrics. Global experts merely offered a knowing smirk. Such a brazen declaration, given the near-identical external appearance of the two machines, stretched credulity to its breaking point. To grasp how Iran suddenly produced a tank of this caliber, one must first understand the nation's preceding technological landscape. The Karrar's emergence was not merely an upgrade, it was a matter of survival, forged in decades of isolation and strategic necessity. By the early 2000s, Iran's armored fleet presented a spectacle that would send any military logistician into a cold sweat. A vast nation, home to tens of millions, encircled by hostile neighbors and choked by relentless sanctions, was forced to wage war with equipment fit only for a military museum. The backbone of its tank corps consisted of machines inherited from the Shah's regime, overthrown by the Islamic Revolution in 1979. American M47 Pattons, designed in the late 1940s, remained in active service. Their contemporaries had long since been melted down, even in developing nations. Iranians attempted to modernize this antique hardware themselves, often with results bordering on the fantastical. The Sabalan tank, for instance, was that very ancient M47, inexplicably fitted with a Slovenian fire control system. On top, a new turret was bolted, transforming the machine into something defying all conventional classification. Yet the Sabalan was merely the beginning. In Iranian hangars, one could find TM tanks, another M47 conversion featuring a new turret and a 108mm gun. Then there was the Sam-Sam, an Iranian iteration of the more modern American M60, also subjected to local engineering modifications. The Safer offered perhaps the most bizarre twist. This was a Soviet T-72, upon which Iranian engineers, for reasons still debated, mounted a smaller caliber gun from an American tank. A patchwork of incompatible doctrines, a desperate fusion of adversaries' technology. What hidden vulnerabilities, what systemic compromises lie beneath the surface of such a desperate, cobbled-together defense? The truth lies buried, obscured by decades of geopolitical maneuvering and desperate improvisation. A stark reality emerges from the shadows of Iran's military arsenal, a chaotic collection of armored vehicles, a bizarre menagerie of American, British, and Soviet designs, each demanding its own unique ecosystem of support. This was not merely inefficiency, it was a systemic vulnerability, a ticking time bomb of logistical failure. British Chieftain tanks, acquired during the Shah's reign, stood as a testament to this fractured legacy. Their transmissions and running gear, once meticulously maintained by Western expertise, were now overhauled by Iranian hands, a painstaking, often futile effort to breathe life into aging giants. Alongside them, American M60s, themselves a relic, and a patchwork of Soviet bloc armor created an impossible demand. Different spare parts, incompatible ammunition, specialized maintenance crews. Each component a distinct, critical headache. This was not a military force. It was a logistical nightmare, a monument to strategic compromise. The roots of this disarray plunge deep into Iran's tumultuous history. For decades, under the Shah, the nation served as a pivotal American ally in the Middle East. Western technology, including cutting-edge armaments, flowed into the country in vast quantities, cementing a strategic partnership built on shared interests and formidable military might. The Iranian military was a showcase of modern Western power. Then came the seismic shift. The Islamic Revolution in 1979, culminating in the siege of the American embassy in Tehran, shattered those alliances. Relations with the West plummeted into an abyss. Overnight, the lifeline of spare parts, ammunition, and new combat vehicles was severed. The sophisticated machinery, once a symbol of strength, became a liability, its operational lifespan dictated by dwindling reserves and the ingenuity of desperate engineers. The true test arrived with the Iran-Iraq War. 8 brutal years of unyielding carnage decimated Iran's armored divisions. Hundreds of tanks were lost, their hulks littering battlefields. With Western supply lines choked by sanctions, replenishment became an act of sheer desperation. Iran scoured the globe for anything that could roll, anything that could fire. T-55s and T-62s were acquired from Libya. T-59s arrived from China. Even captured Iraqi trophies were pressed into service, each addition further entrenching the chaos within the tank fleet. This was not strategic acquisition. It was survival, no matter the cost. By the dawn of the new millennium, the grim calculus was undeniable. Patching together this collection of obsolescence was no longer sustainable. Iran urgently required its own modern main battle tank, a machine designed for the 21st century, not a museum piece. The question loomed: could a nation isolated by sanctions, cut off from global technological advancements, forge a fighting vehicle capable of genuine combat? Or would it merely produce another parade ground curiosity? The answer would prove unexpected, a testament to a nation's resolve under duress. But before the Karrar tank could emerge, Iranian designers embarked on a long, arduous journey of trial and error. Their path began with an ambitious project, cloaked in the evocative name Zulfikar. The Zulfikar project materialized in the early 1990s. Iranian military strategists finally conceded that endless modifications of foreign platforms were a dead end. The nation needed a tank conceived, if not from a blank slate, then at least from a unified design philosophy. Not a Frankenstein's monster assembled from the disparate parts of 5 different machines, from 5 different manufacturers. They chose the Soviet T-72 as their foundation. Iran had already established assembly capabilities for this robust platform during the late 1980s and early 1990s. Yet, simple replication was not the objective. They sought to forge something distinctly Iranian. The outcome was peculiar, a stark illustration of necessity breeding invention. The Zulfikar I, unveiled in 1993 and entering serial production 3 years later, was a profound hybrid. It represented an improbable collision of Soviet tank design principles with American engineering concepts, a fusion born of geopolitical isolation. Its main armament was the Soviet Tu-A-46, 125mm smoothbore cannon, a weapon that had faithfully served T-72s across the globe. But beneath its Soviet-derived turret, a different lineage emerged. The suspension and transmission were directly borrowed from the American M60. a pragmatic choice given the abundance of these aging American tanks still present in Iranian arsenals. To dismantle, to repurpose, to survive. This was the brutal reality of a nation forced to innovate in the shadows, creating machines from the remnants of past alliances and present adversaries. What other compromises, what other dark secrets lie buried within the steel and circuitry of a military-industrial complex forged in isolation? Iran's Zulfikar tank, a defiant symbol of national ambition, emerged from a complex web of foreign dependency. Its final assembly occurred on Iranian soil, yet critical systems and major components were routinely imported, funneled through tortuous supply chains and third-party nations. The first iteration, Zulfikar I, saw approximately 150 units enter service. For a nation striving for military self-sufficiency, this represented a significant, if compromised, achievement. Then came the Zulfikar II, an ambitious upgrade promising a new engine and improved running gear. But ambition often collides with stark reality. Only a single prototype was ever constructed. The project, quietly, vanished. Zulfikar III proved more compelling. It adopted a 7-road wheel chassis, echoing the American Abrams, and integrated an advanced fire control system featuring a thermal sight and a laser rangefinder. A more powerful diesel engine provided its thrust. Around 100 of these machines were reportedly produced. The combined output of all 3 Zulfikar versions barely reached 300 units. A modest figure, indeed, for a country with such grand strategic aspirations. Yet the true value of the Zulfikar project was never in its numbers. It was a brutal, invaluable education. It forged a new generation of Iranian industrial expertise, illuminated critical vulnerabilities within the national defense complex, and revealed the precise points of future leverage. But even as the Zulfikar program unfolded, Tehran was engaged in a parallel, far more critical game. In the nascent years of the 1990s, a monumental agreement was struck with Moscow. The deal encompassed the acquisition of 200 T-72 tanks and, more crucially, the establishment of licensed production capabilities within Iran itself. The transfer included not only the machines, but also the intricate technologies for manufacturing spare parts and a range of vital components. The most coveted prize, however, was not the tank itself. It was the factory. With extensive Russian technical assistance, the Bani Hashem armored plant rose in Iran's Loristan province. This was no mere assembly line. It was a fully integrated enterprise designed to produce a significant portion of components locally, with Russia supplying the remainder. Iranian engineers and technicians toiled alongside their Russian counterparts, absorbing entirely new methodologies and processes, acquiring a depth of knowledge impossible to glean from any textbook. Then, in 1995, the blueprint shattered. Under the crushing weight of international sanctions, Russia abruptly terminated the joint project. The Bani Hashem plant, stripped of its primary purpose, was repurposed into a repair facility. Yet the acquired knowledge did not simply evaporate. It settled. It resided in the minds of the engineers, etched into countless schematics, embedded within newly mastered technological processes. It lay dormant, a potent seed, patiently awaiting its moment. As Iran assimilated this unexpected Russian legacy, something else transpired. A development shrouded in secrecy for years, its true significance largely unknown, yet potentially decisive in the eventual genesis of the Karrar tank. In 1998, rare photographs began to surface across the nascent Iranian internet. A shadow moved across the parade ground. Not a cloud, but a tank. an anomaly in a line of state-sanctioned steel. Upon closer scrutiny, specialists identified a hybrid, a Frankenstein's monster of military engineering. The running gear, a 1,000-horsepower chassis from an export variant T-72AG, supported a hexagonal, welded turret. This turret belonged to the Kharkov Object 478B1. Object 478B1 was a Ukrainian modification of the T-80UD, powered by a 6TD diesel engine. Its defining feature, a fundamentally new turret, fabricated through a process of rolling and welding, a stark departure from traditional casting methods. This was not merely an upgrade, it was a reimagining of armored protection. No official designation exists for this enigmatic hybrid. This absence fuels speculation. The tank was assembled hastily, then covertly transferred. A plausible theory suggests it was siphoned from a batch of T-80UDs destined for Pakistan, slipping away unnoticed, a ghost in a convoy. This clandestine maneuver speaks volumes about the lengths taken to acquire advanced military hardware outside conventional channels. That turret specifically became a veritable goldmine for Iranian engineers. Its structural design mirrored that of the formidable Russian T-90A. Thick frontal armor plates, angled at 45 degrees relative to the gun barrel, encased a potent composite filler. The manufacturing process for these armor plates involved electroslag remelting, a technique yielding 10 to 15% higher material cost, but delivering vastly superior metallurgical properties compared to standard methods. This was cutting-edge protection, not easily replicated. Approximately 30 years ago, this very design found its way into Iranian hands. At the time, it represented the freshest development from the Soviet defense industrial complex, a pinnacle of Cold War engineering. The acquisition was not merely a physical transfer of hardware. It is inconceivable that the tank arrived without its accompanying technological secrets, the blueprints, the manufacturing protocols. The precise methodologies, the specific alloys, the intricate layering of composite materials, these were the true prizes. When the time came 2 decades later for Iranian engineers to design the Karrar, they did not need to invent the wheel, particularly concerning the turret's construction. They possessed a ready-made, tangible guide, one of the finest in the world. The illicit transfer had provided an unparalleled shortcut, bypassing years of research, development, and costly failures. This was not reverse engineering from scratch. It was reverse engineering with a comprehensive instruction manual. At the Bani Hashem factory in Loristan province, as Iranian engineers finally commenced assembly of the Karrar, their initial focus was singular: protection. This was not a design choice, it was a strategic imperative. In a region where anti-tank missiles proliferate among countless factions, where the Israeli army fields some of the world's most advanced armor-piercing munitions, a tank without formidable protection becomes nothing more than a 3-man coffin. The brutal realities of modern warfare dictated every design decision. The Karrar adopted the classic Soviet school of tank layout. The driver mechanic occupies the forward section of the hull. The combat compartment is centrally located, with the gunner positioned to the left of the main armament, and the commander to the right. The engine compartment, the heart of the machine, fills the stern. This configuration ensures a maximally compact armored volume and a low silhouette, critical advantages on the battlefield. A smaller target is a harder target. The machine's hull is a welded structure, incorporating combined protection in its frontal arc. Photographic evidence from early production models suggests the Karrar's chassis is almost identical to the Tagil hull, effectively replicating the T-90M's robust design. this is not incidental. It suggests a direct lineage, a deliberate replication of proven. How many other such ghost technologies, siphoned from collapsing empires and desperate states, now underpin the arsenals of emerging powers, reshaping the global balance of fear? How many more untold stories of clandestine transfers and illicit acquisitions remain buried beneath layers of state secrecy, waiting for their own strange parade? The armored hull sides boast a formidable thickness of 80 millimeters, further shrouded by rubber fabric screens. Integrated within these layers are elements of dynamic protection. With a frontal structure comparable to the T-90M, the hull's equivalent protection against armor-piercing, fin-stabilized, discarding sabot rounds should register around 500 to 600 millimeters. This figure stands before accounting for the reactive armor, which contributes significantly to its defensive posture. Yet the true triumph for Iranian engineers lies in the turret. Recall the enigmatic Kharkiv prototype, a ghost from the 90s that materialized in Iran? Its very architecture became the blueprint for the Karrar's new turret. Iranian designers meticulously reduced its profile, matching the T-90M Tagil, and mirrored its design for the rear ammunition bustle. The turret's thick frontal armor plates are angled at 45 degrees relative to the gun barrel. When facing a direct 0-degree attack angle, this configuration yields an equivalent resistance of approximately 900 millimeters against kinetic penetrators. Incorporating dynamic protection, that figure escalates to 1,200 millimeters against cumulative shaped charges, a capability that aligns with the world's elite main battle tanks. The Karrar's dynamic protection system demands particular scrutiny. It appears to be an entirely Iranian innovation, bearing no direct lineage to the Russian relict or even the Contact 5 systems. Visually, its blocks evoke the Contact 1, but on a scale so amplified they seem to have been injected with raw power. These boxes are simply gargantuan. Given the regional conflict landscape, where diverse cumulative anti-tank munitions pose the primary threat, Iran has clearly prioritized defense against these specific weapons. It is highly probable they have increased the number of internal elements within each block, potentially to 3 or 4 plates. This design choice aims to counteract tandem cumulative munitions, where the initial charge strips away the dynamic protection, leaving the second to strike bare armor. Elements of dynamic protection are also mounted on the turret roof, enhancing survivability against top-attack munitions. These smart weapons, employing an explosively formed penetrator principle, target the tank's vulnerable upper hemisphere. The rear and side sections of the turret, along with the sides of the engine compartment, are shielded by slat armor. These anti-cumulative screens are designed to disrupt RPG-type grenades, detonating them before they can even contact the primary armor. Despite these advancements, glaring deficiencies persist. These shortcomings primarily stem from Iran's inability to replicate or independently develop the very latest Russian solutions. For instance, the Karrar lacks dynamic protection over its track skirts and on the lower frontal hull plate. These critical zones remain conspicuously exposed, a silent invitation for attack. The T-90M, conversely, maintains a superior turret defense, thanks in no small part to its relict system, which adds an additional 200 to 300 millimeters of protection against sub-caliber rounds, and around 500 against cumulative threats. How many more such compromises, born of necessity and geopolitical isolation, lurk beneath the surface of these formidable machines? Beyond its passive and dynamic armor, the Karrar main battle tank deploys a sophisticated aerosol screening system. 6 grenade launcher tubes, 3 on each side of the turret, connect directly to an advanced laser warning receiver. 4 independent detectors, strategically mounted on the turret, ensure an unbroken 360-degree panoramic surveillance. The moment a laser-guided anti-tank missile or an enemy tank's rangefinder illuminates the Karrar, the receiver triggers an immediate, automatic volley of smoke grenades. This response instantaneously shrouds the massive machine behind an eye mechanism also counters radar illumination, effectively mirroring the capabilities of Russia's formidable Shtora system. Recent satellite imagery and ground photographs show the tank cloaked in a distinctive cover, its configuration hinting at the integration of additional, undisclosed optoelectronic countermeasures. Concrete information regarding these potential enhancements remains elusive, buried beneath layers of secrecy and speculation. The Karrar's formidable protection is undeniable, yet even the most heavily armored tank becomes nothing more than a static bunker without a capable engine, or a useless steel shell without potent weaponry. This is where the narrative of Iranian tank development takes its most intriguing and perhaps most deceptive turn. According to numerous foreign intelligence assessments, the Karrar is believed to be powered by a localized variant of the 12-cylinder V84 diesel engine. This unit, purportedly producing a mere 840 horsepower, has been manufactured by Iran since the late 1990s. If these assessments hold true, then with the Karrar's declared combat weight of 51 tons, its power-to-weight ratio would barely exceed 16.5 horsepower per ton. This figure places it squarely in the performance bracket of the British Challenger 2, a tank widely acknowledged for its deliberate, rather than dynamic, operational pace. Western analysts consistently assert that Iran lacks the indigenous technological foundation to engineer a modern tank engine from its very inception. Yet, a stark contradiction emerges. The Karrar's officially stated maximum road speed is 70 kilometers per hour. This figure precisely matches the velocity capabilities of the T-90M, a much-vaunted Russian design. To propel a 50-ton armored platform to such speeds, an output of 840 horsepower is demonstrably, almost comically, insufficient. Here, a different narrative unfolds, one championed by Iranian sources. During the Karrar's public unveiling at the Bani Hashim factory, the official specifications displayed on the tanks themselves bore a provocative claim under the engine power category: more than 1,000 horsepower. A deliberate ambiguity, perhaps, but a direct challenge to the prevailing Western view. Iranian military publications have since offered a more precise figure: between 1,000 and 1,200 horsepower. This range places the Karrar's power output remarkably close to the T-90M's 1,300 horsepower engine. The implications are profound, suggesting an unacknowledged leap in Iranian engineering capabilities, or something far more clandestine. It is not beyond the realm of possibility that the renowned Ural Vagon Zavod, the Russian industrial giant, may have facilitated the production of this new, more powerful motor. This could have occurred through the transfer of a manufacturing license or comprehensive technical documentation, with Iranian engineers subsequently incorporating their own modifications and refinements. The shadows of international cooperation, or perhaps covert assistance, lengthen. Adding another layer to this enigma, recent Farsi language publications across the Iranian internet have heralded the development of a new, indigenous multi-fuel engine. This purported power plant boasts an impressive 1,300 horsepower, along with a significantly increased torque reserve in its higher gears. For context, the Russian V92 engine, powering the T-90M, delivers 25% of its maximum torque at higher gears. The older V84, a mere 18%. The Iranian successor, its developers claim, surpasses both. What hidden agreements, what clandestine transfers of technology truly underpin this sudden dramatic surge in Iran's armored capabilities? What truths remain obscured, deliberately withheld from public scrutiny, concerning the true origin and power of the Karrar's heart? A 30% advantage. This figure alone suggests a profound shift in battlefield dynamics. It means the Karrar's raw tractive power could, under specific conditions, eclipse even the declared capabilities of Russia's flagship tanks. This engineering choice allows the machine to sustain higher gears for longer durations, translating directly into a critical, if often overlooked, fuel efficiency. Its internal tanks, holding 1,200 liters of fuel, grant an operational range of 5,550 kilometers, an astonishing distance, hinting at deep penetration missions or prolonged independent operations. Yet this extended reach comes with a stark caveat. Two external drums, each carrying 200 liters, can boost this range by another 20%. These drums are fully integrated, feeding fuel into the main system as if they were internal reservoirs. But a chilling directive accompanies this tactical advantage. Carrying these external fuel barrels into combat is strictly advised against. A single, well-placed hit to this exposed zone risks a catastrophic fire, an inferno capable of consuming the entire tank. The pursuit of range, it seems, can become a self-inflicted vulnerability. The Karrar's running gear mirrors the modernized T90A and T72B3. Each side features 6 road wheels, individually sprung by a torsion bar suspension system. 3 return rollers guide the tracks, with idlers positioned forward and drive wheels at the rear. The tracks themselves are fine pitch, incorporating a parallel rubber metallic hinge. Intriguingly, options exist for both standard track types and those fitted with bulky, Western-style rubber pads, designed to enhance traction and maneuverability on paved surfaces. A subtle admission of a design compromise, perhaps, or an attempt to adapt to diverse operational theaters. Inside, the driver's station presents a curious blend of old and new. Multiple monitors display feeds from front and rear cameras, offering comprehensive situational awareness. A dedicated multifunctional screen provides navigation, complete with detailed maps and route planning. Yet, control remains stubbornly traditional, managed by levers. This apparent anachronism holds a potential secret. If the Karrar truly incorporates a Tagil-designed automatic transmission, its reverse speed could soar to 15 or even 20 kilometers per hour. A stark contrast to the abysmal 3 or 4 kilometers per hour, typical of its predecessors. In modern armored warfare, the ability to rapidly disengage or reposition backward is not merely an advantage. It is a matter of life and death. Then, there is the Karrar's primary weapon. It fields the time-tested 125mm 2A46M cannon, a design originating in 1980 for the late T-72B and early T-90 variants. Equipped with a bore evacuator and a thermal sleeve, this gun boasts a 1.5-fold increase in effective range against moving targets while on the move, compared to its earlier iterations. However, this version of the cannon lags significantly in precision, roughly 20% less accurate than the more contemporary 2A46 M4 and M5 models. Its effective engagement range is nearly halved. Recent imagery of the Karrar, however, reveals a new detail: a barrel bend accounting device, previously absent. This suggests the Iranians are not static, actively striving to elevate the weapon system closer to modern standards, a desperate attempt to compensate for inherent limitations. To further offset the cannon's shortcomings, the Karrar integrates a missile complex. an exact replica of the Soviet 9K1119M reflex system. This laser-guided weapon can engage targets up to 4 kilometers away, penetrating 700 millimeters of armor behind explosive reactive protection. A formidable capability, yet one rooted in decades-old technology. On the turret roof, positioned aft of the commander's cupola, sits a remotely operated heavy machine gun, a standard defensive measure. These details paint a picture of a tank born of necessity and adaptation, a patchwork of borrowed designs, indigenous modifications, and critical compromises. It is a machine designed to project power, yet burdened by the ghosts of its origins. What, then, does it reveal about the true state of modern armored warfare, when cutting-edge capabilities are built upon a foundation of obsolescence and calculated risk? A tank is a hulking mass of steel, a brute force engine of war. Its heavy armor, its powerful engine, its devastating cannon, these are merely components. Without a sophisticated fire control system, they remain disparate pieces of metal, incapable of effectively engaging targets. It is this intricate network, this digital brain, that binds everything together, transforming a collection of raw power into a truly lethal machine. Here, Iran has delivered a stark surprise, not once, but in multiple critical aspects. Long before the Karrar, their Zulfikar tanks already incorporated a homegrown, remarkably advanced fire control system. This was no crude imitation. It was a direct analog to Slovenia's EFCS 355. A system that, at the time, outstripped many of its Soviet counterparts. Its capabilities were undeniable. A laser rangefinder piercing the battlefield haze for up to 10 kilometers, boasting an astonishing accuracy of merely plus or minus 5 meters. At its core, a ballistic computer, meticulously programmed with the full nomenclature of every available munition. This foundational technology became the grim blueprint for what the Karrar would ultimately receive. Iran, often dismissed, is a nation with surprisingly robust information technology infrastructure and a formidable mathematical school. The world has already witnessed this capability in the precision and autonomy of Iranian unmanned aerial vehicles. Complex machines impossible to engineer without serious electronic sophistication. To underestimate Persian ingenuity in software and electronics would be a dangerous strategic miscalculation. The Karrar's modern automated fire control system is a testament to this prowess. It integrates a multi-channel gunner's sight, offering both high-resolution optical television and thermal imaging channels. A comprehensive ballistic computer processes real-time data from an array of environmental sensors, including meteorological inputs, ensuring surgical accuracy even in the most volatile conditions. For guided missiles, the Karrar employs a backup sight, an adaptation of the Soviet 1K13, complete with its own laser range-finding channel. This component, while undeniably archaic in design, offers a brutal reliability. Its infrared searchlight provides a night vision capability extending to 1,200 meters, a stark, unforgiving eye in the darkness. But the truly unsettling innovation, absent from earlier Karrar iterations and appearing only on the latest models, is the commander's panoramic sight. Mounted adjacent to the remote-controlled 12.7mm machine gun, this device performs a mission-critical function. It grants the commander full 360-degree situational awareness, a complete, unblinking view of the surrounding battle space. Where commanders once strained through narrow periscopes, their vision confined, they now see more than even the gunner. This panoramic eye transforms them into an independent hunter, capable of autonomously identifying targets and cueing them for immediate engagement. The battlefield has no secrets from this vantage. Fire control can be seamlessly transferred between the gunner and the commander, both operating from parallel sites. The system, with high probability, is equipped with an automatic target tracking function. This chilling capability locks onto a target, maintaining the reticle's unwavering focus, and can initiate a shot at the optimal moment, either automatically or with a single decisive press of a button. This level of automation, this relentless efficiency, forces a chilling contemplation. As these machines grow increasingly autonomous, their decision cycles shrinking to fractions of a second. What becomes of human agency on the battlefield? What are the systemic implications when the very act of killing is streamlined, optimized, and detached from the immediacy of human judgment? What future does such calculated lethality portend? A leaked photograph reveals the undeniable truth. At the heart of Iran's indigenous Karrar main battle tank, the commander's information management complex relies on a commercial off-the-shelf Japanese Panasonic CF-19 tablet laptop. This is not a bespoke military-grade system, but the very same ruggedized model prized by automotive mechanics for its resilience and diagnostic versatility. Years of painstaking, expensive development for a dedicated combat computer were bypassed. Instead, Iranian engineers integrated a robust, mass-produced civilian device directly into the tank's sophisticated control architecture. The precise modifications for data encryption and combat management remain shrouded in secrecy. Yet the sheer pragmatism of this decision is both astonishing and deeply unsettling. Targeting data streams across interactive, multifunctional, liquid crystal displays at every crew station. The onboard information management system seamlessly integrates the Karrar into a broader, interconnected battlefield network, orchestrating coordinated unit actions across vast operational theaters. This isn't just a tank, it's a node in a larger, distributed war machine. Beyond the revelations regarding its command suite, whispers persist across the Iranian digital landscape concerning the testing of a novel active protection system. This advanced counter-munition complex reportedly reacts to incoming enemy projectiles, capable of deflecting them with aerosol countermeasures or physically intercepting them with its own dedicated anti-missiles. The Iranian armed forces exhibit an obsessive focus on mitigating the efficacy of precision-guided weaponry. This doctrine extends beyond armored platforms, reaching even individual infantry soldiers. Consider the helmet-mounted sensors unveiled in 2020, designed to detect active laser rangefinders and targeting systems, issuing immediate warnings to soldiers under threat. If such advanced threat detection is deployed for frontline infantry, it would be naive to assume the Karrar, a flagship armored asset, lacks a comparable or even superior defensive suite. The implications are stark. A nation once reliant on refurbished museum pieces is now systematically equipping its forces with layers of protection against the most advanced threats. The Iranian Ministry of Defense has placed an order for 800 Karrar units. Serial production is already in full swing at the Bani Hashim factory. Online footage from the manufacturing floor clearly shows no fewer than 10 tanks in various stages of assembly, a testament to significant industrial capacity. 800 units. That figure alone eclipses the entire fleet of British Challenger 2 tanks. It stands roughly equivalent to the total number of French Leclercs. This is not a limited production run for prestige. It represents a fundamental shift in regional power dynamics. General Qiamars Haidari, commander of the Islamic Republic of Iran Army Ground Forces, boldly asserts the Karrar ranks among the world's top 10 tanks. An audacious claim, perhaps, but the underlying fact remains. A nation that 2 decades ago fought wars with heavily modified historical relics now mass-produces a machine engineered to contend with the pinnacle of global armored warfare. What hidden vulnerabilities lie within this pragmatic integration? What unseen compromises have been made in the pursuit of self-reliance? And what systemic threats does this new paradigm pose to the established order? They called it adaptive resonance, a seemingly innocuous term buried deep within corporate white papers and academic journals. Its true purpose remained obscured, cloaked in layers of technical jargon. But our investigation reveals a different reality. This isn't just about optimizing user experience. It's a sophisticated technique designed to subtly yet profoundly engineer perception, to guide decisions, to craft reality itself. We uncovered evidence of its deployment across multiple sectors: market fluctuations, political discourse, even public health narratives. A silent, pervasive influence, operating just beyond the threshold of conscious thought. Its architects remain shadowy figures, their motives obscured by shell corporations and encrypted networks. This isn't a glitch, it is the intended function. A system built to predict, then to prescribe. The question we must now confront: when the very fabric of shared understanding can be meticulously woven by unseen hands, what remains of our autonomy? What happens when the truth itself becomes just another variable to be optimized?